In this topic, we discuss adding and subtracting like rational expressions. If you recall, adding and subtracting fractions is a little more difficult process than simply multiplying and dividing them. Sometimes it entails us getting what is called common denominators. Well, adding and subtracting rational expressions are done in the same way. It's a fairly complicated process. So for this reason, we've broken up that concept into a few separate topics. In this topic, we look at adding and subtracting rational expressions when they have like denominators. That brings me to my first remark. Like regular fractions, rational expressions can only be added or subtracted if they have the exact same denominator. Notice in the first example, 1/7 plus 2/7 can be added together. We do so by adding the numerators and keeping the like denominator of 7 the same. So our answer of 1/7 plus 2/7 is just 3/7. However, if you can remember, if we tried to add 6/11 plus 3/5, because these denominators are not the same, they cannot be added together. That is, they cannot be added together until we get them into like denominators. We're going to focus on this type of expression where you have different denominators in the next coming modules. But for now, we're going to focus when two fractions or rational expressions have the same denominator. Let's start our explanation with a definition. Two rational expressions are called like rational expressions if they have the exact same denominator. That is, in the first example, 17x over 5x squared plus 25x and negative 2x plus 3 over 5x squared plus 25x are considered like rational expressions because notice their denominators, 5x squared plus 25x, are identical. However, in the second example, 4x plus 3 over x squared minus 1 and 4x plus 3 over x squared minus x, notice the denominators are different. Here it's x squared minus 1, here it's x squared minus x. Therefore, these are not like rational expressions. So, if we have like rational expressions, we can add them and subtract them. To add like rational expressions, we're going to add the numerators by collecting like terms, and then the result is placed over the common denominator. To subtract the like rational expressions, we're going to change our problem to an addition problem by distributing the negative side in the numerator to the second term, the one that the negative sign or the subtraction sign applies to, and then we'll proceed to add like rational expressions. We're going to do a bunch of examples to clarify this. Example 1a. Add or subtract as indicated. Write the result in lowest terms. Alrighty, we have 4/9 plus 2 plus 5x over 9. First thing we observe is that these rational expressions are like rational expressions because the denominators are both 9. They're identical. And how do we add rational expressions? We add them by adding the numerators and keeping the denominators the same. So let's start by adding the numerators. That's going to give us 4 plus 2 plus 5x all over the single denominator, the like denominator of 9. Now we continue to simplify. 4 plus 2 plus 5x over 9. This is equal to, putting like terms together, 6, 4 plus 2 is 6, plus 5x divided by 9. We can leave our answer like that, or if we like, we usually tend to write our polynomials in decreasing order, that is with the powers in decreasing order. So we'd have 5x plus 6 all over 9, and that's the same thing. This rational expression does not reduce. And we're done. Example 1b. Add or subtract as indicated. Write the result in lowest terms. Negative 8a over a minus 5 plus 3a plus 25 over a minus 5. Alrighty, let's begin by looking and noticing that these are like denominators. And therefore we can simply add straight across by adding the numerators and keeping the denominator the same. That is, we have negative 8a plus 3a plus 25. All divided by the like denominator, a minus 5. Good so far? Next we simplify by combining like terms. Negative 8a plus 3a. That gives us negative 5a plus 25 in the numerator, all over a minus 5. Now, we might be tempted to start canceling things right away, but remember, to reduce to lowest terms, we first have to factor. So let's factor the numerator. What can we take out from negative 5a and plus 25? Notice we can take out a common factor of negative 5. Now this is a little tricky because it's a negative factor we're pulling out, but we can handle it. To take a negative 5 away from negative 5a, that leaves us with a. To take out a negative 5 from positive 25, notice that'll leave us with a negative 5, because negative 5 times negative 5 is plus 25, or positive 25. Alrighty, and on the bottom we had a minus 5, and we can reduce this fraction, notice, because there is a common factor. A minus 5 appears in numerator and denominator. So that simply leaves us with negative 5 over 1, which is just negative 5 divided by 1, which is simply the number or the integer negative 5. So our final answer is negative 5. Example 1c. Add or subtract as indicated. Write the result in lowest terms. 2 over y minus y plus 3 over y. We start by observing that these are like rational expressions because the denominators are the same. They're both y. Second, we observe that this is a subtraction, and subtractions are treated a little differently than additions. In fact, let me make a quick remark. When subtracting like rational expressions, do not forget to distribute the negative sign. For example, if we have 2x plus 5 minus x minus 5 with a like denominator, notice that negative sign, that subtraction sign, distributes to both of the terms in the second fraction. It goes to both the x and to the negative 5, and that creates for us a negative x plus 5. Carrying on, we'd simply go on and add as normal. Again, this subtraction sign must be distributed to all the terms that follow it in the numerator. So let's keep that in mind as we go about doing this example up here. 2 over y minus y plus 3 over y. First thing we want to do is we want to put the numerator terms together because the denominators are the same, and doing so we have to remember to carry this minus sign through to each of these terms. So that means in the numerator I have 2 minus y and then minus a positive 3, which is a negative 3. Again, minus y minus 3. That's our numerator. It's all over the common y denominator. Now we can put the terms together in the numerator that are like terms. I have a minus y, that can't be added to anything, and then I have 2 minus 3, which is actually negative 1, all divided by y. There's nothing that can factor out other than a negative sign, so if you want, you could factor out the negative 1 if you want to, and rewrite it as negative 1 times y plus 1, but that's not necessary. You can leave it just like negative y minus 1 in the numerator. Either of those answers is acceptable, can't cancel any farther, and so that would be the result of when you subtract 2 over y minus y plus 3 over y. Example 1d. Add or subtract as indicated. Write the result in lowest terms. X squared over x squared minus 16 minus 7x minus 12 over x squared minus 16. Okay, again observe that in both of these rational expressions we have a like denominator, x squared minus 16. It's the same in both cases. So what do? We combine the numerators and put it over the same denominator. But one more thing we want to be careful of, and we notice that this is a minus sign. And remember, when you have a minus sign in between your two fractions, you need to make sure and remember to distribute that negative sign to both of the terms or all of the terms that appear in the numerator following the negative sign, or the minus sign if you like. Alrighty, so let's go about putting together the numerator. On the top, we have x squared, then minus 7x, and then minus minus, which is plus 12. Again, x squared minus 7x plus 12. That becomes our numerator. And the denominator is the like denominator, which is just x squared minus 16. Cool. Now remember, if we're going to reduce this to lowest terms, we first need to factor the numerator and denominator and see if anything will cancel. We can't just start canceling right away, so we need to factor first. X squared minus 7x plus 12. Well, that's a trinomial, and it factors as x minus 3 times x minus 4. You can check it, right? Negative 3 times negative 4 is plus 12, minus 3x minus 4x is minus 7x. The bottom is a difference of squares, x squared minus 16. That factors as x minus 4 times x plus 4, a difference of squares. When we break things up, or polynomials up into their factored form, then we can see what we can cancel. In this case, notice that we can cancel the common factor of x minus 4. That leaves us in the numerator with simply x minus 3 times 1, which is x minus 3, and 1 times x plus 4 in the denominator, which is simply x plus 4. So our final answer is x minus 3 over x plus 4.